Hi everyone, welcome to one of my sessions to implement resilient applications with API Gateway. I'm super excited to be here. First of all, let me introduce myself. I'm Bob Ur, a developer advocate, and I'm based in Tallinn, Estonia. Also, I have 9 years of experience in IT. I worked in different IT industries including at Microsoft. I was a software engineer and the developer audience lead to build sometimes mission critical .NET applications. And I studied also in Turin, in Italy. That's why I'm really happy to deliver this session. And this time, of course, in English, but I know a little bit of Italian as well. In case you would like to reach out to me on the social channels, I will be super happy. You can always connect me and we can maybe jump into the virtual coffee call and discuss this session's materials. Or if you have any additional questions, feel free to reach out to me. With that, let's get started. Here's the agenda for today. We start with talking about what is API gateway, right? For those who doesn't know yet, I will give a short intro and I will also talk about specifically what is Apache API 6 API gateway. Is one of the API gateway solution. And then we'll walk through the resiliency design patterns and we will understand how to achieve this resiliency and with the help of API gateway features and its plugins. And also then I will have a small demo that shows how fault injection testing mechanism works that is capable of testing your resiliency of your application and APIs. Under the hood, it uses actually the .NET application. You will see in the demo as well. And this is the agenda for today. Now, let's talk about APIs, right? APIs, just 3 letters. Stand for application program interface, right? By now, we are all familiar with this term because we are living increasingly API-centric world. Every service we use today either uses API or this API itself is kind of providing some API features, right? And even nowadays, ChatGPT, one of the hot topic of today's world, it also uses APIs to retrieve all the AI models generated by some kind of intelligent, right? You can use OpenAI API under the hood. Who knows, different REST APIs also interacting with Chat GPT models. And also, we know that success of your service, whatever your service you are building or application, depends on the integrity and performance and availability of your APIs. If by considering that everything is built on the top of APIs, so is a really important component. And here's another question arises, like how we can achieve these indicators of success, as you can see in the screen. One solution can be by using API gateway. What I think you can achieve these 3 indicators and build successful APIs. I will explain why in the next few slides. You will understand. Because in today's world, we are usually creating multiple microservices, serverless APIs, and maybe some other third-party APIs to build some particular product, right? Each time client application should consume one functionality from more than microservices. It means in this request flow, as you can see, API gateway acts as a single entry point for routing all your incoming requests coming from your clients to the backend services. This service can be whether database or maybe third-party service, serverless APIs, and so on, right? In other words, it acts as very single layer between your client application and your backend services. That backend service can be REST APIs or gRPC or maybe streaming APIs which use TSP protocol and so on. And also, sometimes API gateway can act as a central point for observation because it is uniquely identified to know all the moving traffic between the client and your service network, right? As we understood. And also, you can enable such as features like observability features, logging, metrics, and also traces. Also, that also helps you to monitor continuously to achieve to build resilient applications, right? Why I'm starting to show you as an observation is the first step to build something resilient and stable or robust, right? And instead of sometimes integrating your APIs with external tools, technologies, SDKs, you can achieve this work easily by integrating all of these to API Gateway because API Gateway already provides built-in solutions. You don't have to build on your own. You can just use existing features. Because API Gateway further can be extended with countless plugins to handle the other cross-cutting concerns like we call it like authentication, authorization, traffic control, and security, like maybe request transformation, rate limiting, and so on. And also, from the other hand, the most observability platforms like a famous one, Prometheus, Skywalking, OpenTelemetry, also provides some kind of pre-built-in connectors that you can easily integrate them with API Gateway, and then you can leverage these connectors to ingest log data from your API Gateway to further drive useful metrics or into the maybe some monitoring tools, right? And also now, in the next following slide, I would like to introduce you one of the famous open source project called Apache API 6. It's also open source cloud native API gateway where you can use and implement these API gateway features together with plugins. So maybe you might heard already the largest open source foundation, Apache Software Foundation. Maybe you are already part of this community. Just leave your comments to me if you are already committing any of the Apache open source projects. I'm also officially committer. And you may know like a famous open source project like Apache Kafka, Cassandra, Tomcat, right? And also Apache API 6, one of the fastest growing project of this Apache. You can learn more about on the documentation and can just maybe go through the Apache API 6 website if you would like to learn more about it. But one of the cool things I like in this project is sometimes these existing plugins, I told the previous slides, it can be not enough to meet your business requirements, right? Sometimes you need to create your custom plugin to add some additional functionalities. It means you need to write in your favorite programming language to create these plugins. For example, if you're a Java developer or maybe .NET developer or Python, JavaScript, you can use this for programming language you know so far, and then create your own plugin. This is one of the features that I love. Or if you hate writing any code, you can use low-code plugin orchestration feature where on the UI, it's also open source. I mean, it's for free. You can just drag and drop existing plugin to the drawing board to create your own plugin. You can orchestrate one or multiple plugins together to build something complex. Also, you can export these plugins to the outside world to use this configuration with other API gateways than Apache API 6, right? This is two features that I really recommend you to use. But now let's switch back to our initial topic, like about the resiliency, right? Resiliency is ability to recover from the failures and continue to function. I would say it is not about preventing your APIs from the failures, but by accepting the fact that our service always fails, and it responds this kind of failures by avoiding downtime and data loss, which is really important in these world's applications, right? Models applications. And the main goal of resiliency is to return this failed application to fully functional state, normal state, as fast as possible. That's the main responsibility of resiliency, right? For example, when you work with distributed systems like microservices, always remember the number one rule. Everything can happen or everything can fail. We might be dealing with network issues, right? Service unavailability, application slowness, maybe, or an issue with one system might affect another system, right? Or dealing with any such unexpected failures and network issues could be quite difficult and challenging. Here's where API Gateway comes in to help us to build resilient APIs. On this slide, as you can see, I listed out some of the commonly used design patterns nowadays. Now let's break down each design pattern and understand how we can add these design patterns out of the box to our API or application without writing any code, with easy steps and with fast configuration. Let's start with rate limiting. Rate limiting, as the name suggests, right, is capable of limiting number of requests that can be made against your APIs over a period of time. And the use of rate limiting is typically refers to rejecting requests based on the properties of individual requests. Let's say too many requests coming from your API consumer, or maybe by specific application, or maybe by location. In this example, for example, API Gateway, if you think in the middle, it can fetch all the coming requests and see if too many requests are made by mobile application towards to our attendee service. If you're thinking of building conference application, mobile application, where you can see some sessions available, maybe some speakers, almost maybe you can sign up for speakers and so on. This is just a typical scenario what I'm showing. This is a rate limiting you can enable with API Gateway, just adding additional configuration for your upstream, in our case, attendee service. Next can be design patterns load shedding. It refers to rejecting requests based on the overall state of your backend service. Let's say mobile application is still trying to access attendee service, but maybe this attendee service is under heavy load, or maybe there is no more worker threads available in the worker thread pool. So in this case, you can also use API Gateway to test periodically if attendee service is ready to serve our requests by applying load shedding mechanism, right? Next in our list is SWORD design pattern. Now today you will learn more design patterns. Of course, it's really cool. Sometimes due to some network issues, the upstream service might not respond, right, as you expected. And we don't want to wait like indefinitely, right? We don't want to block any threads. In this case, you can specify timeout durations for different use cases and the flows with the help of API Gateway. You can specify, okay, this is a read timeout, this is a send timeout to attend this service, and then your service can be more stable. Or maybe you can use a fallback mechanism. Sometimes maybe you want to not only, let's say, respond immediately to the timeout, but maybe you can handle some network related issues and make the system still functioning by caching some responses as a fallback. Let's say your attendee service cannot respond, and you can have a copy of this response in the cache. That API Gateway also provides a caching mechanism that you can fall back always to cache the data and return immediately to the request from the mobile application, right? This is a fallback. And next, for example, you can also enable some kind of redundancy of your service. You can create one or more instance of your services to achieve like a backup feature, right? If attendee service A is failing and cannot respond now, you can always switch and route the traffic to service B, which is actually now online and healthy, and then can resolve your requests. This sometimes redundant instance always used by DevOps, let's say, to make a canary release or A/B testing and so on. This is quite famous, like kind of a technique that can be used to build resilient applications. And next one, I think that most of us know already in .NET also, there's a special libraries to build resiliency application, like you can enable health check endpoints on your .NET application configuration, right? Because now we separated API gateway into separate component. We can just replace this backend application with whatever application we built by using any framework, any programming language. It doesn't matter. In our case, .NET, let's say, for example, API can periodically request this health endpoint to identify if this upstream service is available and it's ready to serve our requests. Like maybe you can test like every 5 seconds. You can specify the time, how frequently, and API 6, like API gateway, can check health check endpoint of attendee service. So, and also after you enable the health check endpoint, and your next step can be, okay, now what if my service now is not responding? Maybe I can give a try one more time. That's a retry mechanism comes in. Okay, I can transparently try to retry failed operations after maybe some delay or immediately. Like you can maybe send a request first to attend the service, and it doesn't respond. Maybe it responds with server error, and then you can try after 2 seconds again to check if attendee service is ready. Why it is good? Instead of mobile app calling this attendee service many times, right? It means mobile app is not aware of what's happening behind the scene. It doesn't care about these failures, but API gateway can handle these failures like automatically, and you just reduce also number of calls from mobile application and service. It means it reduces latency, right? This is very logical. It has a connection to many other problems we are facing nowadays as a software engineer or the developer of our APIs. Or sometimes the retry mechanism can be not enough. In this case, API gateway such as Apache API 6 also can offer special API breaker plugins that implements circuit breaker mechanisms to invoke and then handle failures, sometimes prevent upstream services from constant retry attempts, because sometimes you don't want to constantly retry, there's no success, right? And it's when your application performs slowly or maybe failing and cannot respond anyway. And because circuit breaker, it's able to monitor the number of recent failures that have occurred by now, and then it uses this information to decide further allow to this operation go to upstream service, or immediately Apache API 6 API gateway can return like a fail fast approach, like, okay, now we cannot serve a request, sorry. You can show the error on the user side immediately in order to not to block mobile application. Let's say if it's loading on the screen, it is also not a good experience for your users, right? And next, for example, you can use, on the top of my head is a bulkhead pattern. Also, I use it sometimes. For example, as the name says, if one of your node, it's more about in, let's say, how to say, in the service layers, like not an API gateway layers, it can check the node 1 or node 2, node 3. If one of the node is failing, it can always send some additional connection requests. And you can specify maximum requests, how many requests you can send to the virtual node. What I'm saying, you can separate the consoles, like all get requests can go to node 1, all post requests can be node 2. Like there is also quite famous design pattern like SQLS, common inquiry, separate aggregation, somehow to call it, but you can separate get and post requests to different instance of your service, right? This is also how it's called bulkhead. And one of the services failing, you can always use another service on the time. Now, I will bring your attention to the small demo. Why this demo I prepared to understand and give you the knowledge that, okay, we know now some design patterns, right? And that can be helpful for us to fight against some kind of failures, right? To build a robust application, and how we can test this actually before our application or API goes to production. There is one quite good approach called fault injection testing. That's I'm going to show you how to achieve fault injection testing at an API gateway level to test this resiliency design patterns or resiliency of your application is perfectly set or not. On staging, maybe on development phase. Fault injection testing approach, the API gateway level, as I said, can be used to test resilience of application or maybe microservice APIs against various forms of attacks. Let's say the technique can be used to inject delays, sometimes abort requests with a user-specified error codes, like as a HTTP error codes. And it provides ability to stage different failure scenarios such as service failures, service overloads, right, or high network latency, and so on by injecting these mock errors. For example, Apache PSX has a fault injection plugin. You can enable this plugin to inject delay or abort requests from one service. And also you can maybe write some integration tests, E2E tests. Let's suppose that we have online shopping sample application that consists of many microservices such as catalog, product, order, and so on. When we are retrieving data about products belonging to specific catalog service, there is always service-to-service interaction, right, between catalog and product. In this case, something might go wrong. Any number of reasons here can happen, right? Now, our task to test this catalog service, how it reacts in case product service is failing and cannot respond on time, and maybe it has a latency. This we can test with fault injection testing. As you can see, fault injection testing is just a plugin. If you navigate to Apache PSX website, there is a plugin hub. You can just scroll down. You can find the fault injection as a injection icon on it, and just you can have a look how to enable this plugin. And also, I prepared my demo repo on GitHub. This I'm sharing maybe with most of the people. There is not only fault injection example, but the other examples like how you can achieve API observability, how you can enable red teaming, and so on. You can learn it. But once you clone this project and go and open it with your favorite editor, you can just add some configurations. Let's say if you add a fault injection plugin, if you want to use it, you need to specify it under a config YAML file. And because we are using Docker, I can bring all necessary containers with the Docker Compose app just quickly, right? As you can see, I'm using Windows operating system on my machine. Docker desktop is installed. After I do the Docker Compose app, you can see all the containers available, like API 6, etcd. It's a backend for API 6 project, and Grafana, Prometheus, like that can be helpful for you to monitor your APIs. And next, for example, I need to enable fault injection and abort requests. This is a very typical example. It can be a little bit difficult to understand here, but you can also take a look at my blog post. There is a very nicely explained the command itself, this Carol command. For example, we are enabling a plugin for /API/products, which is .NET web application that can delay some HTTP request. That's I'm saying, okay, this is a delay. Please put a delay. Let me explain actually shortly here. I'm saying I have .NET application with a single endpoint. Let me. I think there was a connection cut. All right. Let me switch back. So now it's good. I had one connection back. Sorry for that. And as you can see, I have. I'm running Carol command. you can use Postman, or you can even use UI dashboard if you don't want to write any curl command. As you can see, I am trying to access admin API of Apache API 6. It's for all type of configuration you can do. I am creating new route here. I'm creating new route object by requesting API 6 admin API, and I'm using just to secure this connection API key that can be replaced with your own API key, right? And I'm creating new route to test this fault injection plugin. And what I'm saying, all coming GET requests to my .NET Web Application Endpoint API products should be always checked by API 6. If this request comes, immediately we need to enable this fault injection plugin. What does it mean? We are injecting some delays. We are saying, let's assume that our product service now has some delay. And we are saying 100% of time, it is responding us in 5 seconds. It's actually very quite a long time, right, for APIs responding like a TLL, but in this case, it should be at least less than 1 second. And now we put like 5 seconds to test how catalog service reacts on it, right? Catalog service should say or some kind of error to my mobile application or my web application, actually, who is requesting this service. If you run this simple curl command, admin API responds okay, and here you can also see in this JSON configurations upstream also. We're configuring upstream. In our case, our product API only with single node. You can have a multiple node, by the way. Like if you would like to achieve this redundancy pattern or bulkhead, you need to specify more instance of product API to fall back sometimes if one of the product API is not responding. It's an upstream object inside the route object with the plugins and upstream itself. And we are using just by default round robin. It's a routing algorithm. You can choose your another algorithm as well, but it's preferred always to use a round robin by default. Even you can remove type of routing. It always use round robin. And now it is actually good. Our first fault injection plugin is enabled. As you can see, then I am trying to run this curl command against my API product. I'm putting this time to see if actually my product service responding in 5 seconds. If I play again, as you can see in this demo, after 5 seconds, my product API service responds back to me after some delay. As you can see here, I have a delay introduced, like 5 seconds in real user, and I have some response. I am getting product details, like 2 products only in my market. You can have more if you wish. And this is a kind of how you can enable fault injection when you are writing some integration tests. You can, for example, write in the next step integration test that can enable this injection plugin and make a calls to API products to test how your catalog service or product service is resilient enough, right? It can be automated. Now, in our case, we are doing manually, but it can be automated with, let's say, some of the frameworks you are using for .NET. Next, me try to enable aborting HTTP requests with some kind of custom errors. In this example, second example is, as you can see, I'm changing fault injection plugin configuration. In this case, not a delay, but I'm using abort. What does it mean? We are saying every request, 100% percentage of requests, all should be rejected by API gateway before it goes to product service. With this status, and we see a body response as error message, right? It's very straightforward. To test my catalog service, how it reacts. This is how we are putting some abort requests by using API gateway, and the same similarly using upstream product service. So if you try to run this carol command. In a moment, you will see this fault injection plugin is enabled, and then you are actually getting some HTTP error call because like a product service is currently unavailable error. That's how actually our API gateway work at the present. Now, as we are coming to this demo part, like I say, as you can see here, I'm again doing simple curl command to slash API slash products endpoint. And if I hit the enter and run this curl command, you will see I will get immediately some kind of error because now I cannot see actually product list, but I am getting some kind of simulation, like a simulated error. Let's say product series now currently unavailable. That actually, as we expected, right? Now you can also in the next step implement, add this API call to your integration test, right? And end-to-end integration test and test this functionality easily. That's how this demo can be helpful shortly for not only developers, also for QA engineers, testing developers also can use this feature to simulate some kind of errors. Of course, some of the API gateway providers also has these features. As far as I know, also AWS has this kind of simulator for its API management solution. But it's open source, it's for free and ever evolved. It's a part of community project. And before we end this session, I have some takeaways for you. As you can see, what we learned, like we learned some resiliency design patterns. Not all of them, we have many of them. I only listed out like 9 of them, but the resiliency design patterns are always a rescue. Try to use these design patterns and implement and bring to your application APIs. And also you can use this resiliency of your APIs. You can test with fault injection approach. Not only in the API gateway level, there are other ways of using this FIT. And also you can use a simple built-in API management solution to efficiently observe your APIs. As I showed, like you can easily enable this observation plugins. Also, you can put on the top of everything some security like authentication and authorization without additional code change or re-architecting your existing application. I'm here just in case, leaving out all the necessary references and useful links for you. And now I can finish my session. In case you have a question, just let me know. Feel free to reach out to me. I am also leaving here my Twitter account, or maybe you can reach me on GitHub, but I will be happy. So with that, I can finish my session. Thanks a lot for your attention. In the chat, I will always welcome your questions. Thank you, guys. Take care.